Hello, hello. Yes, we welcome you back to PSSB, Physical Sciences, Silver Bullet, and it's me, Richard, here. Um, Today we are looking at this question. It says that the human ear can detect sound waves of the frequency range 20 to 20,000 Hz. And the question says, identify the term used to refer to sound of frequency below 20 Hz. Okay. Yes, what do we call the sound which has frequency below 20 Hz? So before we delve into the question, I would like to remind you to subscribe. The channel is PSSB, Physical Sciences Silver Bullet, and it's me, Richard, here. Okay. Sounds which have frequency below 20 Hz, what do we call them? We call them infrasound. Okay, that's that. Then sounds which have frequency above 20 Hz, what do we call them? We call them ultrasound. Okay, then comes the next question. It says, what is meant by ultrasound? What are they? Okay, generally ultrasounds are sounds with a frequency higher than 20,000 Hz up to 100,000 Hz. So that range between 20,000 Hz to 100,000 Hz, that the sounds with that range, we call them ultrasounds. Let us put them down. So that is that. Then let us go to the next question. So then comes the next question. It says that the application of ultrasound in medical and industrial fields is based on creation of images. Briefly explain how ultrasound form images. Okay. Ultrasound, it can pass through material. It can be transmitted through material, but part of it is reflected. So the degree or amount of ultrasound which goes through the material is dependent on the density of the material. So if the material is thicker or more denser, less ultrasound passes through and more of it is reflected. If the material is of less density, more ultrasound pass through and less is reflected. So upon that variation in reflected rays, the reflected ultrasound is gathered and it forms the image. So when you look at our tissue has various materials. We have the bone, which is thicker, the tissue, which is far less denser. We have the muscles, which are yellow. So all those tissues have different densities. So when ultrasound is bombarded onto such a material, there's various degrees of reflection, and those reflected ultrasound gathered to form an image. So that is briefly how ultrasound form images. It is based on the density of materials. Okay, let us put that one down. So there we are. It says when ultrasound travel inside material, some is transmitted and part of it is reflected. The degree of transmission or reflection is determined by the density of material. So the varying reflected rays when ultrasound travels through material such as human tissue is used to construct image of the object. So remember, different densities, different degree of transmission, and a different degree of reflection. And those varying degrees of reflection those are used to construct the image. So let us see what happens next. So next question comes and it says, list any 3 medical applications of ultrasound. Okay, what are the applications of ultrasound? Okay, the first which we can, there are several, we are just going to pick some few. One is that it is used in the treatment of cancer. Okay, ultrasound makes materials to vibrate, makes cells to vibrate at very awkward speed, and that one at a times leads to the death of the cells, and those cells include human cells, which might be cancerous. Okay, ultrasound is used to break kidney stones. And it's the same mechanism. It makes the particles to vibrate and it ends up dissolving, breaking down, and then breaking down kidney stones. Another use is that we saw it that it can be used to monitor the growth of a fetus. So by forming images like we have seen before, we can tell whether the image which we are observing is of a normal fetus or abnormal fetus. So it points out the abnormalities in case they are there. So, and so many others. It can be used in cleaning of teeth and several others. So that is that. Then comes the next question. It says, list any 3 industrial applications of ultrasound. Okay, what are they? We saw the sonar, sound navigation and ranging. Ultrasound can be used to determine the length of a material or width of a material. It can be used to visualize welded joints to detect defects. Some of these joints are of very important parts like aircrafts. So, and a small defect can be catastrophic. So, yes, we can use it to visualize welded joints. We can use it to clean jewelries, to clean lenses, and the other materials. So let us put them down. So that is that. And with that, we would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet. And it's me, Richard. Don't forget to subscribe. Don't forget to like, and also to refer this channel to a friend. Like I always tell you, We believe this is the best channel in this aspect, and you will not regret. See you next time. Bye bye.